Hi guys and welcome to today's video, which is a Year 8 video on operations with fractions. Yes, thank you very much for joining me. If you are new to my channel, really good to see you. Now, this is a consolidating lesson and builds on the work from probably years 5, 6 and 7. So if you are watching this, you are looking to just make sure you totally understand how to add, multiply, subtract and divide fractions, not necessarily in that order. If you are new to my channel, there is a little doohickey in the corner. If you could click it and subscribe, I would be deeply grateful. Why? Well, long story short, well, I just want to know you're watching. I'm never going to get rich, never going to get famous. Only about 8 people watch these videos, but it just keeps me going knowing that people are watching. There is also MaffsGuru.com where all of these videos are listed by textbook and by chapter, so you should be able to find them with downloadable notes to put in your book if they make sense, with lots of examples. That's always good. That's what I was told. So, operations with fractions. This is a first lesson dealing with a series with real numbers. Now, I record these videos basically dealing with all of real numbers, then all of Pythagorean trig, all of number and place value. So you won't see a whole year level be created. You'll see sort of year 8, year 9 and year 10 videos created over this series. Much of the work has already been covered, as I said. Now, the 4 operations with fractions, and I know no one likes fractions. I get it. I really do get it. I wish I understood why people don't like fractions. But sadly, you've buried your head in the sand for long enough. We have to make this work. You have to remember this. Use your summary book. Use whatever method you can. Practice. I recently gave my maths group 84 pages of fractions, decimals and percentages to do. 84 pages with about 100 questions on each page. That's 8,400 questions. Hopefully by the end of my teaching, they will be guns at fractions. Why? Because they're really important. They're used in so many areas of mathematics so that if you can't do fractions, you're in all sorts of trouble. And turning around saying to yourself, nah, I've never been able to do them. Well, I don't know, I've never been able to decorate a house, but I learned because I needed to. If you guys want to continue with maths, really do need to sort fractions out. So we're going to do fractions, but by multiplying, dividing, adding and subtracting, because that's the easiest way to do them. That's the easiest order. So do a couple of recaps. Number 1, whole numbers are fractions. It is really important to know that you can turn any whole number into a fraction. So the number 12, is that a whole number? It is. And all I need to do is divide it by 1. Because 12 divided by 1 is still 12. But now you'll notice it's a fraction. 14 would be 14 on 1. 1,234 on 1. 6.7 on 1. Small problem there, ladies and gentlemen. We are not allowed to have decimals and fractions mixed together, but we'll deal with that in another video. So the whole point of it is whole numbers are fractions as well. This becomes important because you can only multiply, divide, add and subtract fractions when they look like a fraction. And maths is going to try and trick you. Cancelling down fractions. So many of you lose marks left, right and centre because you don't cancel down. Why? Because your times tables suck. I'm sorry, that hurt, I know, but it's true. Again, bury your head in the sand. Turn around and say, I can't do this. At the end of the day, you are 12, 13 years of age, and I am desperately hoping that at some point you're going to turn around and say, well, while your 6-year-old brain may have had difficulties, your brain's a lot more advanced now, and it does mean you just have to sit down and rote learn them. There's no other way around it. If not, you're going to lose marks simply because you can't divide a number by 2 or 3. Sad but true. So if I have the number 12 on 15, if you don't automatically look at those 2 numbers and say they're both in the 3 times table, then you're in trouble. You're gonna struggle. And so because I know they're both in the 3 times table, it means I can divide both the top and the bottom by the same thing. Why? Because that's what cancelling down is. You divide the top and the bottom by the same number. Why? Because then it doesn't change the size of the number. 12 divided by 3 is 4. 15 divided by 3 is 5, and then I stop. Again, why? Because I've looked at this and my brain says the only times table that has the 4 and the 5 in it is 1. And I can, by all means, divide the top and the bottom by 1, but I'm going to get back to 4/5, and it seems fairly pointless. What about 16 on 20? Again, I can look at this and say 8. No, the easiest number to do here is 2. Why do I halve them? Well, A, my brain is pretty good at halving values. B, because the top number and the bottom number are both even. So again, my brain is looking at these fractions and looking for patterns, the quickest way or the simplest way of doing it. So I'm going to divide the top and the bottom by 2. Remember, it has to be the same thing, which is going to give me 8 divided by 10. Am I going to leave it there? Nope, I'm going to check again. What times table does 8 and 10 go into? Well, again, they're both even numbers, so I can divide by 2 again. Divide by 2, which gives me 4 on 5, and it was a huge coincidence that actually ended up to be the same. But the point of it was, can I go any further? Nope, not at all. What about cancelling down other fractions? What about if I have 1 and 20 on 45? Well, that's a mixed number. And in many cases of mixed numbers, we can ignore that 1 altogether. Let's just undo that because I was wanting to highlight it. We can ignore that 1 altogether and just deal with the 20 on 45 first. So I know the 1's going to be there, and I'm looking for a number that goes into both 20 and 45. Well, my number facts tell me that if a number ends in a 0 or a 5, the chances are it's divisible by 5. So I'm going to divide the top by 5 and the bottom by 5. The 1 stays. 20 divided by 5 needs to be, use your fingers, 5, 10, 15, 20. That's 4. 45, 5, 10, 15, 20, 25, 30, 35, 40, 45 on 9. And ladies and gentlemen, once again, there is my end, because I know that there is no times table that has a 4 and a 9 in it. Cancelling down, really important, but you have to do it to its lowest possible way. Oh look, mixed numbers. I just said we were talking about mixed numbers. It is easy to convert mixed numbers into top-heavy fractions. Now, in many cases, having top-heavy fractions, improper fractions, is going to make life a lot easier for me. Now, 1 and 2/5. Now, there are all sorts of ways of doing this. I have taught it in all sorts of different ways. There is 1 whole 1. So I've got 1 whole pizza, and I've got 2/5 of a pizza. So what I'm now looking at is the fact that that bottom number there tells me how many slices my pizza has been cut into. So I have 1 whole pizza, which is now cut into 5 pieces, and I've got 2 pieces of another pizza. So the question is, how many pieces do I have altogether? I have 5 and 2, which is 7. So I have 7 pieces of pizza that were cut into 5 pieces. Now, lots of people go, oh my God, that's awesome. Other people go, I have no idea what you're talking about. Sadly, again, 3, and he writes 2, 3 and 4/7. So I have 3 whole pizzas, and I've got 4 slices of a pizza. Out of how many? Well, again, we look at the bottom here, and we've said that each of our pizzas has been cut into 7 pieces. So I've got 7 pieces here, 7 pieces here, 7 pieces here, and 4 pieces there. So how many pieces do I have altogether? 7, 14, 21, 25. So I have 25 slices of pizza when my pizza has been cut into 7s, or 25/7. Again, that's one way of doing it. When I was at school, I was taught to do it a different way. I'll go back to the 1 and 2/5. Now, I've written a shortcut here. I hate shortcuts unless you understand why they really work. But my math teacher taught me, take the big number, multiply it by the bottom number, and then add the top number. So 1 times the bottom number, add the top number. So 1 times 5 is 5, plus 2 gives me 7, and make sure that you remember it's 7/5. Let's do 3 and 4/7. 3 and 4/7. Remember, it is the big number times the denominator, add the numerator. So 3 times 7 plus 4. 3/7 are 21, 25, divided by, make sure you always write that 7 there, 25 on 7. This is only going to happen with practice. You have to do a lot of practice of this, guys. Now, multiplying fractions is the easiest one in the possible world to do, because you multiply the top numbers and multiply the bottom numbers. Simply it. So if I have 2/3 times 3/4, I am simply going to do the top numbers multiplied together and the bottom numbers multiply together. So 2 times 3 divided by 3 times 4. 2 times 3 is 6. 3 times 4 is 12. And I'm going to leave it there. Yes? Nope. Because you have to cancel this down. Is there a number that goes into 6 and 12? Well, there's actually 2 numbers. 3 numbers. I can divide both of those by 2. Why? Because they're both even numbers. I can divide them by 3. Why? Because 6 and 12 are in my 3 times table. I can also divide them by 6. Why? Because 6 and 12 are in my 6 times table. And in this situation, I'm going to choose 6. 6 divided by 6 is 1. 12 divided by 6 is 2. And there we go. We have 1/2. Now, what I want to say to you, ladies and gentlemen, this is going to come important a little bit later on, is that we all know that 2 times 3 is exactly the same as 3 times 2. When everything is connected by a kissy or a times, we can change the order of these things around. So 2 times 3 is the same as 3 times 2. So actually, I could, for this one here, have done 2 times 3 divided by 3 times 4. I could rewrite that as 3 times 2 on 3 times 4. Why is this going to be important to me? Well, we also are going to find out a bit later on that we can cancel stuff down. We happen to know that when there is a number on the top and the bottom of a fraction, so long as they're all being timesed, we can divide them, cancel them down, whatever you want to call. 3 goes into 3 once, 3 goes into 3 once, and so I have 1 times 2, which is 2, 1 times 4, which is 4, and I know both of those can be divided by 2, which gives me 1/2. Now you're going to say that's a lot of work there. I know. But in year 10, year 11, and year 12, if you can't mix things around, divide, cancel, you're going to find maths really, really challenging. In fact, probably not going to do well at all. So let's do another one. Let's do 4/7 times 3/5, for example. Same. 4 times 3, 7 times 5, 4 times 3 is 12, 7 times 5 is 35. Is there a number that goes into 12 and 35? Nope. And so actually I'm going to leave that one there. Now there are shortcuts to know whether this can be cancelled down, and I'll come back to that. We can continue. We can do 1/2 times 2/3 times 3/4. The rules don't change. When you multiply fractions, you multiply all the tops together. So we're going to multiply all the tops together, multiply all the bottoms together, and lo and behold, so 1 times 2 times 3 on the top, and 2 times 3 times 4 on the bottom. So that gives me 6 on 3 times 4 is 12, 24. Is that the end? Nope, because I can cancel this down. Again, I know that 6 and 24 are in my 6 times table. So 6 divided by 6 is equal to 1. 24 divided by 6 is 4. And lo and behold, there we have our answers. But again, if I'd known my fraction tricks, I could have written that as 2 times 3 times 1 divided by 2 times 3 times 4. Do you see why? I've got a 2 on the top and the 2 on the bottom. They're all kissing. I've got a 3 on the top and a 3 on the bottom, still kissing. And so I can now do 2's into there goes once, and 2's into there goes once, 3's into there goes once, 3's into there goes once, and if we notice, our top is now 1 times 1 times 1, which is 1, and 1 times 1 times 4, which is 4. Yes? Can we do this with mixed numbers? Absolutely. Let's do 1.5 times 2/3. We have a mixed number. My advice to you is to turn it top heavy or improper. So using the rule, big number, 1 times 2 is 2, plus the 1 is 3. That now becomes 3 on 2. I'm going to times that by 2 on 3. 3 times 2 is 6. 2 times 3 is 6. And any number that's divided by itself is always going to be 1. I don't think it's fractions that particularly throw people. I think it's all the shortcuts and the things that people don't remember, all the tips and the tricks. Anything you learn from these videos should be written in your summary book in your own words. Yes, you can download these notes, you can print them off, but these are my words. You need to write it in yours. Dividing fractions, absolutely awesome. Why? Well, it's the next one. It's the one that's a little bit more challenging, but it isn't, because it is keep, change, flip. Or for those of you who teach me Kentucky chicken that's fried, whole new discussion. So I'm going to write keep, change, and flip. Note here, for those of you who want to do maths later on, Flipping a fraction is called taking the reciprocal. When you change it, when the numerator becomes the denominator and the denominator becomes the numerator, that's called taking the reciprocal. It's just maths terminology. So if I want to do 1/2 divided by 2/3, for example, we cannot divide fractions. We have to change it around, and we say that we keep the first one. So you keep the first one, which is a half. You change the divide into a times, and you flip the second fraction. Fraction. Reciprocate it. So what was on the bottom, so do you notice the 3 is on the bottom? It now becomes on the top. Do you notice the 2 was on the top? It now becomes on the bottom. And lo and behold, you have not finished the question. You now multiply them using the rules you had before. Top 2 multiply together and bottom 2 multiply together. So 1 times 3 divided by 2 times 2, which is 3 on 4. Can I cancel that down? Nope. And that's it. There's nothing more to dividing. Let's do 7/9 divided by 1/3, for example. Okay, so keep the first one, 7/9. Change and flip it upside down. So what was 1/3 becomes 3/1. And just multiply them together. 7 times 3, 9 times 1, 7, 14, 21, divided by 9. And again, this is where your times tables come in. Do you know what your times tables are? 3s. 3s go into both of these. So 3s go into that 7 times. 3s go that into 3 times. And lo and behold, we are done. Yes? What about mixed numbers? Does that work? 2 and 2/5 divided by 1/2. Well, turn it top heavy first. So turning it top heavy, big number times the bottom number, add the top number. So 2 times 5 is 10, add 2 is 12 on 5. Remember, it's that bottom number there. Divided by big number times the bottom number is 2, add the top number is 3 on 2. Can we divide them? Nope, we are going to keep the first one, 12 on 5, change that to a times, but turn these to 2 on 3. Right, 12 times 2 is 24, 5 times 3 is 15. What goes into both of those numbers? Well, I happen to know 3, because I know my 3 times table. So 3's into that go 8, 16, 24, 8 times. 3's into that go 5, and so we have 8 on 5. Is that how we leave it? Nope. All right, you can't leave fractions as top heavy, so you have to reverse it. And the way I think about this is how many 5's go into 8? 1 whole time. How many left over? 3. All right, so 1 3/5. Yeah, this top value here is effectively your remainder. So you do 8 divided by 5 in your head. You go, well, it goes once. How many got left over? 3. And you just make sure you write that 5 on the bottom again here. So that's dividing fractions. Adding fractions is interesting because that's where people start to get a little bit screwy. We have to use similar fractions, all right? And that's fine. We understand how to do that, but we need to make sure that when you add or subtract fractions, you have a common denominator. You cannot add fractions together when the bottoms are different. Just doesn't work. You have to use your times table knowledge to make the bottoms the same. So common denominators first. If I do 1/2 plus 1/2, what is the denominator of this fraction? Well, it's the numbers on the bottom. Are they the same? They are indeed. And so when you add fractions, you only ever add the top 2 values together, or the tops. You add the numerators. You only ever add the numerators. So I'm now going to do 1 plus 1, because I'm adding the numerators, but the denominator stays the same. I don't do 2 plus 2. 1 plus 1 is 2 divided by 2, which is 1. Because remember, when you have a number divided by itself, it's always 1. And, you know, we were expecting that. If we had half a cake, added half a cake, we would get 1 whole cake. What about 1/3 plus 4/3? Can we do that? Absolutely. The bottoms are the same. The denominators are the same. So I can do 1 plus 4 on the top. The denominator stays the same, and that becomes 5 on 3. Can I leave it that way? Nope, I have to make it mix. So the question is, how many 3's go into 5? Well, it goes once, with how many remainder? 2. So 1 2/3. So long as you write that 3 on the bottom there, and you remember that this value here is the remainder, you should be able to do this all of the time. Now we're going to do some examples with different denominators. 1/2 plus 1/3. Are they the same? They are not the same, so we can't add them. I have to now use a trick to make the bottom numbers the same. And the easiest way to do that is to say, well, I'm going to multiply by 2 and 3. Now what I mean by that is I'm going to multiply this one by 2 and this one by 3. Why? It just works. This would have been explained in a year 7 video. I'm just recapping the work. Now what we've got to remember is when we multiply a fraction, we've got to multiply both the top and the bottom by the same thing. So the top has to be multiplied by 3. Let's write that in red, sorry. So the top has to be multiplied by 3 there, and the top has to be multiplied by 2 there. So let's deal with this fraction first. We're just going to multiply the top and the bottom by 3. 1 times 3 is 3. 2 times 3 is 6. Job done. We're now going to add on. 1 times 2 is 2, and 3 times 2 is 6. And do you notice what's now happened? The denominators are the same. Now that they're the same, I add the numerators and leave the denominator as it is. So that becomes 5 on 6. And that is in fact my correct answer. Let's do another one. Let's do 2/5 multiplied by, oh no, not multiplied, added to 1/3. Are the denominators the same? No, they are not. I have a 5 and a 3. So what I do is I'm going to multiply, but by the other one. Does that make sense? So this one I'm going to multiply by 3, and this fraction I'm going to multiply by 5. So I'm going to multiply that whole fraction by 3, and I'm going to multiply that whole fraction by 5. When you multiply, top and the bottom have to be multiplied by the same number. So 2 times 3 is 6. 15 times 3, 5 times 3 is 15. Plus, now we're going to multiply this one by 5. 1 times 5 is 5. 3 times 5 is 15. Are my denominators the same? They are. Life is good. And so that becomes 6 plus 5 on 15. Which is 11 on 15. And that can't be cancelled down. So life is good. And we can do the same with mixed numbers. 1/2 plus 2 and 1/3. Now, I always turn these top heavy. A lot of textbooks get you to put the numbers to one side and whatever. I don't do that rubbish. No. I will always turn it top heavy because it just makes sense to me to do that, and it's easier in the end. So 1/2 becomes 3 on 2. Remember, 1 and 1/2 is 1 times 2 plus 1. I'm going to add that to 2 and 1/3. So the big number times the denominator. 2 times 3 is 6 plus the 1, which is 7, and make sure it's on 3. Are the denominators the same? No, they're not. I've got a 2 and a 3. So what I'm going to do is multiply this one by 3 and multiply that one by 2. I'm just taking the denominators and swapping them and multiplying by that. So multiplying all of this now by 3 gives me 9 on 6 plus 14 on 6. Yeah, because 7 times 2 is 14, 3 times 2 is 6. Are my denominators the same? They are. So that becomes 9 plus 14 on 6, which gives me 14. 23 on 6. Is that how I'm going to leave my answer? Nope. So I say, how many 6 are in 23? 6, 12, 18. So that's going to give me 3 whole ones, 18, 19, 20, 21, 22, 23. Gives me 5 remainder, and we've got the 6 because this bottom number here and that bottom number there have to be the same. That is adding fractions. Guess what, ladies and gentlemen? Subtracting fractions is exactly the same, but this time we're going to subtract. And so if I have 2/3 minus 1/2, are the bottoms the same? No, they are not. So what am I going to do? I'm going to turn the bottoms the same. I've got a 3 and a 2, so I'm going to multiply that fraction by 3 and that fraction by 2. So 2 times 2 is 4. Remember, you have to times the top and the bottom. Times by 6. 3 times 1 is 3 because I'm multiplying this top number by 3, divided by 2 times 3, which is 6. Oh, my denominator's the same. They are. I'm in heaven. So that becomes 4 minus 3 all on 6, which becomes 1 on 6. Can that be cancelled down? Nope. Let's just do a mixed one. Let's do 3.5 minus 2 and 1/4. Okay, ready? Absolutely. So we're now going to do top heavy that 6, 7 on 2 minus 9 on 4. Now there are lots of ways of doing this. I can multiply because I notice the bottoms are different, and I could, if I wanted to, multiply that by 4 and multiply that by 2. But one of the interesting things to know is what we're trying to do, believe it or not, is we're trying to find the lowest common multiple of those two numbers. Now if you don't understand what lowest common multiple is, it's trying to say what is the lowest number that both 3 and 2 goes into, or what is the lowest, what times table has both 3 and 2 in it. I want to ask the question here, what times table has both 2 and 4 in it? What's the lowest common multiple? Well, as it turns out, it's the 4 times table. All right, so if I look at the 4 times table, I have 4, 8, 12, 16. If I look at the 2 times table, I have 2, 4, 8, 2, 4, I can't do my 2 times table, 2, 4, 6, 8. What do I notice? 4 comes into both of them, and so 4 is my lowest common multiple. So what I'm actually going to do is change the bottom of these fractions to 4s. How do I do that? Well, has that changed? No. So that doesn't change. Has this value changed? Yes, it's gone from a 2 to a 4, so it's actually doubled, which means I have to do the same to the top number there, and it becomes double. So now, are the bottoms of my fractions the same? Yes, they are. And so 14 minus 9 is 5. On 4, is that my answer? Nope, because 4's going to 5 one time, remainder 1. So 1 and 1/4. Let's do another example, a simpler example. Let's do 2/5 minus 1/15. Okay, now I happen to know that 5 goes into the 15 times table, all right? Or rather, 5 divides into 15. So what I'm actually going to do is I'm going to make the bottom of both of these fractions 15. Yes, you can times this one by 15 and you can times that one by 5, but it just makes more work for you because you then have to cancel down later on. So I have got a 5 on the bottom here, but a 15 on the bottom there. How have I gone from 5 to 15? I've times by 3. So that suggests that I've got to multiply that whole fraction by 3. So that becomes 6 on 15. Has this value here and this value here changed? Nope. So if it stays the same, then the top stays the same as well. Are the bottoms the same? Yes, they are. So that stays the same. I can write 6 minus 1, which gives me 5 on 15. And can I cancel that down? Yes, because my 5 times tables becomes 1 on 3. Now, I've already sort of alluded to this previously, but cross-cancelling when multiplying fractions makes life so much easier because you don't have to cancel down at the end. So if I have 1/2 times 2/3 times 3/4 times 4/5, for example, that seems to be fairly disgusting because at the moment I would have to do 2 times 3 times 4 times 5, 1 times 2 times 3 times 4. Well, if you remember, I could write this out as 1 times 2 times 3 times 4 divided by 2 times 3 times 4 times 5. A bit of buzzing, it just crashed. So what I could do is do 1 times 2 times 3 times 4 divided by 2 times 3 times 4 times 5. Now, okay, we've seen that before. But remember, I can move them around. If they're all kissing together, I can move them all around. That could become 2 times 3 times 4 times 5 divided by 2 times, times 1 divided by 2 times 3 times 4 times 5. And what do you notice? We have 2 on the top and 2 on the bottom. 3 on the top, 3 on the bottom. 4 on the top, 4 on the bottom. And as such, we can cancel those down because 2 divided by 2 is 1. 3 divided by 3 is 1. 4 divided by 4 is 1. And that actually becomes 1 on 5. Now that's the long way of doing it. There's actually a quicker way of doing it. If there is a number on the top and a number on the bottom that are the same, we can cancel them out. Doesn't matter where they are on the fraction, as long as they're all times. So what do I mean by that? Let's get rid of the yellow. Are all the tops times? These are the questions you ask yourself. Yes. Are all the bottoms effectively times? Yes. So what I'm now going to do is say there's a 2 on the top here that cancels with the 2 on the bottom there. Now when I say cancels, we just do 2 divided by 2. They become 1 on 1, and it is so important to write the ones. There's a 3 on the top here and a 3 on the bottom there. There's a 4 on the top there and a 4 on the bottom there. And so if I now look at my tops, I've got 1 times 1 times 1 times 1, which is 1, and 1 times 1 times 1 times 5, which is 5. Notice it got rid of all that rubbish in the middle. There were different ways of doing this, all right? 1 times 2 times 3 times 4 on 2, 3, 4, 5. We can actually cancel in any way we like. It's easier to cancel a number on the top and a number on the bottom. But what do we notice here? I've got a 2 on the top. 2's into there goes once, and 2's go into there twice. I can absolutely do this. 2's into 2 go once, 2's into 4 go twice. What do I notice? 3's into 3 go once, 3's into 3 goes once. And I happen to notice now that I've got a 2 here and a 2 here. So 2's into 2 go once, 2's into 2 goes once. And what am I left with? 1 times 1 times 1 times 1. 1 times 1 times 1 times 5. Oh my goodness gracious me. All right, one more. So 2 thirds times 6 sevenths times 4 tenths times 1/3. We'll just make this up. Are they all multiply together? Yes. So the tops and the bottoms I can cancel as I wish. So let's see. 3's go into there once, 3's go into there twice. What else have I got? 2's go into there twice, 2's go into there 5 times. Anything else? Can I cancel top and bottom? Nope. And so, ladies and gentlemen, I now know that I've done all my cancelling down at the start. So we get 2 times 2 times 2 times 1, which happens to be 2 times 2 is 4 times 2 is 8, divided by 1 times 7 times 5 times 3. 7 times 5 is 35. 35 times 3, let's just do this pencil paper, 15, which is 105, which is 8 on 105. And ladies and gentlemen, I'm done. Okay, so this has been a long video, 33 minutes. I am so sorry, but it is reviewing all of this work. Simplify the following. Are the bottoms the same? Yes. So we're adding fractions. We just add 3 plus 4 divided by 5, which gives me 3, 4, 5, 6, 7 on 5. That is improper. So 5's into 7 go once with 2 left over. So that becomes 1 2/5. 5/3 minus 3/4. Are the bottoms the same? No. So I have 5/3 minus 3/4. The 3's and 4's, does 3 go into 4? No, it doesn't. So what I'm now going to do is use this times that fraction by 4 and times that whole fraction by 3. So 5 times 4 is 20. 4 times 3 is 12. Minus 3 times 3 is 9. 4 times 3 is 12. The bottoms are now the same. So I get 20 minus 9 on 12, which gives me 11 on 12. That's not top heavy. We leave that one there. We got a mixed number added together. Not going to phase me at this moment in time. First thing we're going to do is turn it into a top heavy. So we've got 3 5/8 plus 2 3/4. So 3 times 8, 8, 16, 24, that's 29 on 8, plus 8, 9, 10, 11 on 4. So the question is, does 8 go into 4? No. Can 4 go into 8? Yes. So actually, I'm going to make them both 8 on the bottom, because it's just going to make my life a little bit easier. This number hasn't changed, so that stays as 29. This number has become twice as big, so we need to make that number twice as big. Are the bottoms the same now? Yep, so 29 plus 22 on 8, which gives me 40, 51 on 8. And again, if you don't know your times tables, this is where you're going to fall over. 8, 16, 24, 32, 40, 48. So it goes 6 times, 48, 49, 50, 51, and 3 8s. Let's just write that with 6 and 3 8s. 2.5 minus 1 and 5, 6. Again, write it as top heavy. 2.5 minus 1 and 5, 6, which becomes 5 on 2 minus 6, 7, 8, 9, 10, 11 on 6. So we ask the question, does 2 go into 6? Let's just undo those 2 strokes. Does 2 go into 6? I should cocoa, so in which case it makes sense just to leave them as 6s. How have I gone from there to 6? How have I gone from 2 to 6? It's 3 times bigger. So I make the top 3 times bigger. I'm going to multiply that by 3. Has this number changed? Nope. So this number stays the same as 11. So that becomes 15 minus 11 all on 6, which becomes 4 on 6. That's my final answer. Yes? Nope, because they're both even numbers, so they can cancel down to 2/3. I know I'm doing these quickly, but the great thing about having video is you can stop it. You can look at my working out, download the notes. They're all here, and you can go through it and say, okay, do I understand what he did? No, go and play it again. Listen again. Multiplication. Yes, we love multiplication. They are simple because I just do 2 times 3 on the top and 5 times 7 on the bottom. 2 times 3 is 6. 5 times 7 is 35, and I can't cancel that down. Now, how did I know I couldn't cancel that down? Because there's nothing on the top and the bottom that will allow me to cancel it down. What about this way? Hard way. Okay, so let's do this in 2 ways. This is way number 1. 8 on 5 times 7 on 4. So we're going to multiply the tops together. 8 times 7, 5 times 4. 8 times 7, 49, 56. And 5 times 4, which is 20. They are both even numbers. So I'm going to cancel that down to become 28 on 10. And again, I can cancel them down because they're both even numbers, which gives me 14 on 5. That now means that I've got to write that as a mixed fraction. 5, 10 goes in 2 whole times and 4 left over. Okay, now that was the hard way. What if we'd done it the easier way with cross cancelling? Let's actually not have that as one whole line there. Let's make it, okay, so can we see? Well, I notice that 8 and 4 could be cancelled. So 4's going to that once and 4's going to that twice. And so I now can have 2 times 7 on 5 times 1, which gives me 14 on 5, which is 2 and 4/5. Cross cancelling makes life a lot easier. Once again, let's do this one. 3 1/3, that becomes, so 3 1/3 multiplied by 2 2/5. Let's make that top heavy. It becomes 10 on 3 multiplied by 10, 11, 12 on 5. Now I'm going to see if there's any cross cancelling I can do. There is. 5's going to there once, 5's going to there twice, 3's going to there once, 3's going to there 4 times, and so I end up with 2 times 4 multiplied on, which gives me 8 on 1, which is just 8. Remember, this, whenever I'm dividing by 1, just means it's a whole number. I know this video is long. I'm sorry, but you've got to get this stuff correct. Finally, let's do some divided questions. 2/5 divided by 3/7. Well, 2/5 divided by 3/7. We can't divide, so we're going to keep, change, and flip. Can I do any cross cancelling there? Nope. So that's going to become 14 on 15. And that is the end. If you don't know why, then it's 2 times 7 is 14. 5 times 3 is 15. And we are done. And finally, oh, there's more. 5 8 divided by 15 on 16. So 5 on 8. Keep, change, and flip. And in this situation, I notice that 8 goes into there once and 8 goes into there twice, cross-cancelling. 5 goes into there once, 5 goes into there 3 times, and so we end up with 1 times 2 on 1 times 3, which becomes 2/3. Can't make that any simpler. And then we have our final question, which is 2 1/4 divided by 1 1/3. So let's make these top heavy. 8, 9 on 4 divided by 4 on 3. So we're going to keep, change and flip. Can I cancel any of those down? Nope. Bearing in mind, people will be tricked. They'll think that they can be divided by 3. Yes, they can, but not in fractions. One of the numbers has to be on the top. One of the numbers has to be on the bottom. And so that becomes 9, 18, 27 on 16. 16 is going to there once. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and 11 on 16. Ladies and gentlemen, that was long, yeah? There was a lot in that video, and the next few videos are going to be very, very similar, and I'm probably going to ask you to watch these in your own time. If you're in my classroom, if you're in YouTube land, good luck. I'm fairly sure no one's going to want to sit through 42 minutes of fractions, but hopefully you found it useful if you did. If you haven't already done so, can you do me the honour of subscribing? Greatly appreciated. Just lets me know that people are watching. Spread the word. TikTok me. That would be greatly appreciated. Otherwise, I look forward to seeing you in another video. Take care. Have a good day. I'll speak to you soon. Bye-bye.